Hi, and thanks for tuning in to GoVirtual.tv. The topic of discussion for this video is raw device mappings. Now, what is a raw device mapping? It's basically a LUN on the SAN that we take a virtual machine and its guest operating system and install it into that LUN on the SAN, as opposed to the conventional path of taking a virtual machine and installing it into a folder on a VMFS partition or VMFS formatted LUN referred to as a data store. And the idea is that instead of us having that VMFS bound VM, we instead take that virtual machine and point it at a LUN on the SAN, which is carved up and presented through the fiber channel or the iSCSI storage fabric. It should be noted that there is no such thing as an NFS based raw device mapping, and whenever you're making the choice between fiber channel or iSCSI or NFS, if you're at that stage, remember that there is no option for an RDM within the world of NFS, because NFS is actually a file-based file sharing mechanism as opposed to the random access block mode I/O associated with fiber channel or iSCSI. Now, getting started off here, what we're going to do is we're going to create a new VM, and for our virtual machine configuration option, we're going to specify custom so that we can actually use the RDM option. Next, continue. And we'll go ahead and call this S2K3_RDM. And in this screen right here, it's asking us for which data store we actually want to put the VM. Now, the first question at this point will be, if we're installing the virtual machine into a LUN on the SAN, how come it's prompting us for a data store? And the answer to that question is for the configuration information. Remember, it's not just the hard drive that makes up a virtual machine. A virtual machine is actually made of several different elements, including its hardware description file, the configuration file for that VM, for example, how much memory it has, the MAC address for its virtualized VNIC, so on and so forth. We have the vSwap file, we have the snapshot files, we have a variety of other files that are external to the hard drive of a virtual machine, and we have to have some place to put them, and that's why it's prompting us for the VMFS. So we'll go ahead and select Shared Fiber Channel LUN 5. Next, continue. And for our operating system, we'll go ahead and specify a Windows Enterprise Edition 32-bit VM. Next, to continue, we'll go with the standard default 1 processor. We'll crank up the memory to 1 GB of memory for this VM. We'll stick with the default of a single VNIC. For our bus adapter, we'll stick with the default, which is a LSI Logic SCSI adapter. Now, the next option is to select a disk, and most of the time option number 3, which is raw device mappings, is grayed out. And the reason for that is that if the ESX host cannot see an available LUN presented through the storage fabric, it's not going to give you the option of installing a raw device mapping. For all of your VMFS partitions, once there has been a VMFS signature applied to a LUN and that has VMFS information on that LUN itself, it's then considered a data store by the ESX host and it's protected, and that's why we would never see our VMFS partitions or VMFS LUNs at this juncture, just based upon the fact that it's protected by virtue of its VMFS signature which exists on it. Now, the next screen we see where we select and configure the raw LUN, and we have a grand total of 4 LUNs available to us through the storage fabric. We see that LUN 0, the lowest LUN within the order, that's our boot LUN right now, and that's currently carved up at 7 GB. We also have LUN 1, 2, and 3, each of which are 10 GB in size, and what we're going to specify as LUN 1. And the main thing to take back from this particular screen is that the LUNs that are presented through the storage fabric are only the LUNs that do not have a VMFS signature on them. As soon as we take an ESX host and we prepare a LUN with VMFS and we start to install VMs onto it, it goes through a process called signaturing, and that signature basically presents to the ESX host that it has VMFS on it and we're not to use it for any other purpose. And the only type of LUNs that we would see at this point right here are going to be raw LUNs that don't have any type of VMFS signaturing information on them. So we're going to select LUN 1. Next, to continue. And this option is going to ask us where we want to store the LUN mapping. It's usually safest to stick with the virtual machine itself. We would actually store it within the same directory as the configuration information for that VM, but it does give us the option to specify a separate data store if you wanted to do that. Next, to continue. And this brings us to the two types of compatibility modes for a raw device mapping. The first mode, and the mode that we're going to select, is physical. And what a physical RDM is where we have the virtualized SCSI host controller inside the VM itself put into a special mode of operation called pass-through mode. And pass-through mode essentially means that the guest operating system can speak directly to the storage fabric, and with exception to one single SCSI command, every other SCSI command is passed directly through that LUN, and for all practical purposes you could think of the guest operating system and the virtual machine being attached directly through the storage fabric to some type of a LUN that's been carved up and zoned out to each one of the ESX hosts that you want to be able to vMotion to and from. It should be noted that the zoning for a raw device mapping should inherit the same zoning as the parent VMFS in order to have the maximum level of mobility within that vMotion boundary for the ability to live migrate that VM and for it to participate within an HA and or a DRS, distributed resource scheduling cluster. Now, physical mode is probably the most compatible with applications that require some type of a physical hard drive. For example, many instances of Microsoft clustering services require that shared quorum drive be an RDM for the state information, which is shared by and between the cluster nodes. If you have some type of a specialized application, that's usually the primary impetus for going with a raw device map and RDM. Now, when we look at the performance characteristics of a VMFS compared with an RDM, there's about a 1 to 2% performance increase by going with a raw device mapping as opposed to a VMFS, depending on the workload of the VM. However, I would be quick to point out that you would never want to install a virtual machine into a raw device mapping purely for performance reasons. There's other ways that you can get significantly higher performance at the disk storage layer. For example, 64K cylinder boundary alignment will get you much more higher performance than the act of going with an RDM, because when we look at raw device mapping bound virtual machines, there is a pretty significant administrative overhead associated with them. We have to maintain separate zones for the raw device mappings as opposed to a VMFS, which we set at one time and we're done with it. In addition to that, the use of a raw device mapping can also complicate things like taking snapshots. For example, if we were to install a VM into a physical mode RDM, we have no snapshot capability. And if you were to look at some of the things that would potentially affect, for example, no VCB, we would not be able to use VMware Consolidated Backup because the process that is used by VCB to gain access to the underlying VMDK, which is the disks for a virtual machine, is done by way of snapshots. So with a physical independent disk or a physical RDM, we would not have the ability to perform snapshots, which means some things would not work, such as VMware Consolidated Backup or the snapshot feature associated with the VMware Update Manager. In addition to that, don't forget about the 256 LUN limitation within ESX, and that's current as of VMware ESX 3.5 Update 3. If we were to take a look at the Configuration Maximums Guide, which is a part of the main documentation corpus for VMware ESX 3.5, we would see that there is a 256 LUN limit, and multipathing counts against that as well. So physical mode RDMs or virtual mode RDMs. Virtual mode gives us the ability to actually preserve VMFS-like functionality and that we can still take snapshots. So you could probably see that a virtual mode RDM is preferable to a physical mode RDM, especially if you're going to be using things like VMware Consolidated Backup or the VMware Update Manager in conjunction with virtual machine snapshots. We'll go ahead and select physical for right now. Next, to continue. For our advanced options, we'll stick with the default. And last but not least, we have the final task pane here that whenever we click finish, that task is going to be started to create the VM. And we see here that underneath the disk option, we have elected to use a mapped system LUN as opposed to a VMFS bound VM. Now we're going to edit the virtual machine settings before submitting, which is going to give us an opportunity to go in and to attach an ISO image to that VM, which I'll do right now by selecting the CD/DVD drive, selecting the ISO data store, connecting it at power on, and then browsing into our shared NFS to connect an ISO image to the VM. Now once we've done that and we select finish, the VM will be created in just a few moments and we can power it on. Now here is some interesting behavior about raw device mappings compared with a VMFS based VM. Namely that whenever we go to turn on the virtual machine itself, it doesn't immediately prompt us for the install process. And I haven't quite figured out exactly why that happens, but I would say that right now it's probably trying to boot directly from the RDM instead of booting from the CD-ROM drive, so it would appear that there's something that happens with the virtualized BIOS. Normally with the VMFS-based install, we actually have the virtualized CD-ROM interface, which is promoted in the BIOS above the local CD, or above the local hard drive rather, so that the VM, as soon as we power it on, will boot directly from the CD. And that's not the case with raw device mappings, and it can be somewhat frustrating at first. And the easiest way that I've found to actually install a RDM based VM is to use the escape menu, which is going to pull up a secondary boot menu. And if we click anywhere within the black area here for the console, that's going to capture the keyboard, monitor, and mouse, and it's going to put us into that VM. And remember our Control-Alt-Insert keystroke combination, which raises a Control-Alt-Delete within the VM itself. And whenever we do that, here's the process. We're going to do a Control-Alt-Insert to reboot the machine. Right now it's actually running and just sitting there doing nothing, trying to boot probably from the master boot record on the RDM, which has not been installed yet. We're going to do a Control-Alt-Insert, and almost simultaneously we're going to hit the escape key one single time to bring up the secondary boot menu, which should then cause the Microsoft Windows 2003 installer to kick off. And you have to be quick on the draw, so here we go. Control-Alt-Insert, escape, and there we go. If you hit escape twice, it's going to escape out of the boot menu, so you'll have to practice it a couple times to get it right probably. But from here, we select the CD-ROM drive, enter, and that begins the installation process for Server 2K3. And if we were to look at the way that disk is presented, it looks no different than any other type of installation. We'll have a 10 gigabyte disk, which is now available to us, which is actually a LUN on the SAN. And instead of the VM being installed into the VMFS, we now have that virtual machine, which is installed directly into a LUN on the SAN, which we'll be able to format now, and we see that it's a little bit over 10 gigabytes in size, 10,237 megabytes, so 10 gigs, which is the disk 0. And it should be noted that the virtual machine has no concept of a storage fabric. It doesn't see anything related to Fiber Channel or iSCSI. It simply sees its local PCI-X virtual host adapter connected to a virtual hard drive. That virtual hard drive in this instance is actually a LUN on the SAN that will now be natively prepared and formatted with the NTFS file system. Now, one of the other benefits to mention about raw device mappings compared and contrasted with a VMFS-bound VM is, for example, SAN management. We would now have the ability to use any of our native SAN management tools like backup utilities or revision control utilities or whatever we may be using at the actual SAN storage layer. And this virtual machine installed into a raw LUN on the SAN will now appear to be no different than any other physical type of PC that had an HPA inside of it and we'd installed Windows on top of. For more videos of this nature, please visit govirtual.tv. Until next time.